Hello, my name is Jesse Moss, and today I'm going to talk about HTTPS and FTPS. In this presentation, we're going to briefly discuss HTTP, the basics and history of HTTPS, as well as how HTTPS works, then move into a little SSL information. In the next section, we will look at TLS and the basic properties. Next comes FTP. In this section, we will look at the timeline of creation, define FTP, dive a little more into SSL, including FTPS implicit and explicit SSL. We also discuss SSL certificates and firewall incompatibilities. Finally, we finish up with a comparison of HTTPS and FTPS. First up, HTTPS. HTTPS stands for Hypertext Transfer Protocol over SSL. But before we get into HTTPS, we need to discuss HTTP to understand where HTTPS came from. The Hypertext Transfer Protocol, HTTP, is an application-level protocol for distributed collaborative hypermedia information systems. It is a generic, stateless protocol which can be used for many tasks beyond its use for hypertext. A feature of HTTP is the typing and negotiation of data representation, allowing systems to be built independently of the data being transferred. HTTP has been widely used by the World Wide Web since 1990. HTTP 1.0 includes a specification for a basic access authentication scheme. The scheme is not considered to be a secure method of user authentication, as the user name and password are passed over the network as unencrypted text, unless, of course, used in conjunction with some external secure system, such as a secure socket layers or SSL. RFC 2616 was originally used by itself on the Internet. However, due to changes in security's requirements, it has become necessary to include security measures. Because of this new requirement, SSL and TLS were created and designed to provide channel-oriented security. Now that we've discussed HTTP, we can now move into the basics of HTTPS. HTTPS stands for Hypertext Transfer Protocol over SSL, Secure Socket Layer. It is a TCP/IP protocol used by web servers to transfer and display web content securely. The data transferred is encrypted so that only the intended recipient can read the data. HTTPS is used by any website that is collecting sensitive customer data such as banking information or purchasing information. If you are making a transaction online, you should make sure that it's done over HTTPS so that the data remains secure. Now let's talk about how HTTPS works. First, the HTTPS protocol secures a communication connection between the browser and web server for Microsoft Windows users. Then it uses certificates to determine the server identity and create the secure browser connection. From there, it uses a public key to encrypt the data, including user login information and passwords as they pass over the Internet. A main difference between HTTP and HTTPS is that HTTP uses a port 80 to connect while HTTPS uses port 443. Another major difference is that HTTPS encrypts the data by using SSL, while HTTP sends the information as plain text. TLS, Transport Layer Security, was created as a successor to SSL and is most often used as a setting in email programs. However, like SSL, TLS can have a role in any client-server transaction. Now let's talk a little bit more about SSL. The primary goal of SSL is to provide privacy and reliability between two communication applications. The SSL record protocol is used for encapsulation of various higher-level protocols. An example of an encapsulated protocol is the SSL handshake protocol, which allows the server and client to authenticate each other and negotiate encryption algorithm and cryptographic keys prior to the application protocol transmitting or receiving a single byte of data. The SSL protocol provides connection security that has three basic properties. First of all, the connection is private. Encryption is used after the initial handshake to define a secret key. Next, the peer's identity can be authenticated using an asymmetric or public key cryptograph. And lastly, the connection is reliable. The message transport includes a message integrity check using a key message authentication code. SSL has three specific goals. We will discuss each one separately. First of all, cryptographic security says that SSL should be used to establish a secure connection between two parties. Next, interoperability says the interdependent programmers should be able to develop applications utilizing SSL 3.0. that will then be able to successfully exchange cryptographic parameters without exposing code. Third, extensibility provides a framework into which a new public key and bulk encryption methods can be incorporated as necessary. This also accomplishes additional goals of preventing the need to create a new protocol and avoiding the need to implement an entire new security library. The final goal is relative efficiency. Cryptographic operations tend to be highly CPU intensive, particularly public key operations. Because of this, the SSL protocol has incorporated an optional session caching scheme to reduce the number of connections that need to establish from scratch. This also reduces network activity. The next section we are going to discuss is TLS, Transport Layer Security. Transport Layer Security provides communications privacy over the Internet. Many consider TLS to be an upgraded version of SSL. Like SSL, it allows client-server applications to communicate without the threat of eavesdropping, tampering, or message forgery. The TLS primary goal is to provide privacy and data integrity between two communicating applications. It is comprised of two layers, the TLS record protocol and the TLS handshake protocol. The TLS record protocol has two basic principles. The connection is private and it's reliable. In order to ensure the connection is private, symmetric cryptograph is used for data encryption. The keys for the symmetric encryption are generated uniquely for each connection and are based on a secret negotiated by another protocol. The record protocol can be used without encryption. In order for the message to be reliable, the message transport includes message integrity checks using a keyed MAC address. Secure hash functions are used for MAC computations. The record protocol can operate without a MAC, but is generally only used in this mode, while another protocol is using the record protocol as a transport for negotiating security parameters. Moving on to FTP, File Transfer Protocol. The process started in 1971 when FTP was drafted for use with Scientific and Research Network ARPANET. Only a small number of military sites and universities and a narrow community of users who could operate without data security and privacy requirements within the protocol had access to ARPANET. As ARPANET gave way to the NSFNet and then eventually the Internet, a wider population potentially had access to the data as it traveled increasingly longer paths from client to server. The opportunity for unauthorized parties to eavesdrop on data transmissions increased accordingly. In 1994, the internet browser company Netscape developed and released the Application Layer Wrapper, SSL. This enabled applications to communicate in a private and secure fashion, discouraging eavesdropping, tampering, and message forgery. Although it could add security to any protocol that used a reliable connection, it was most commonly used by Netscape with HTTP to form HTTPS. Moving into 1996, SSL protocol was applied to FTP with a draft request for comments. This RFC was not finalized until 2005, 9 years later. FTP provides the capability to upload and download and delete files as well as create and delete directories, and finally read directory contents. When FTP was designed, security was not a major concern. However, over the years, sending information without encryption is considered very risky and in some cases is prohibited. In order to implement security measures, FRP employed SSL and TLS protocol for channel encryption. This new version of FTP is called FTPS. A little more information about SSL. You'll remember from our timeline a few slides ago that in 1994 Netscape developed and released the Application Layer Wrapper. This wrapper began enabling applications to communicate in a secure fashion. Although SSL could add security to any protocol using a reliable connection, it was most commonly used by Netscape with HTTP to create HTTPS. Merging the ideas of FTP and SSL, let's discuss FTPS implicit SSL. Implicit SSL mode requires an SSL session to be established between the client and the server prior to any data being exchanged. The requirement for SSL is implied, therefore any connections attempted by a client not using SSL are refused by the server. Implicit SSL mode generally runs on port 990, but it is now considered obsolete due to the more favored use of FTPS explicit SSL. FTPS explicit SSL mode requires the client and server to negotiate the level of protection to be used. This is more convenient because the server can support both unencrypted FTP and encrypted FTPS sessions on a single port. The process begins with a client establishing an unencrypted connection to the FTP service. Prior to confidential information being exchanged, the client requests the server switch the command channel to an SSL encrypted channel by sending the auth TLS or auth SSL command. Once this is successful, the client sends the user credentials to the FTP server. The credentials and commands are automatically encrypted for the remainder of the session. Now let's talk about SSL certificates. Like HTTPS, FTPS may provide a public key certificate. These certificates may be created using Unix tools such as OpenSSL. The certificate should be signed by a certificate authority, or the FTPS client could create a warning stating that the certificate is not valid. Because of the use of a dynamic secondary port by FTP, firewalls designed to snoop FTP protocol control messages to determine the secondary data connections that need to be allowed may encounter issues if the FTP connection is encrypted using TLS or SSL. This causes the firewall to be unable to determine the TCP port number of the data connection negotiated between the client and the FTP server. This can cause the FTPS deployment to fail. In order to solve this issue, a limited range of ports for data can be established, and the firewall can be configured to open these specific ports. Lastly, let's compare some of the attributes of HTTPS and FTPS. The difference between FTP and HTTP is that FTP is used to connect to a file server while HTTP connects to a web server. When FTP appears in a URL instead of HTTP, it means that some form of file transfer will take place. Both FTP and HTTP are used to upload and download data from the internet. FTP's file transfer purpose is more or less for website maintenance and batch uploads, while HTTP is for client end work and for end users to upload things such as movies, pictures, and other files to the server. HTTP headers contain metadata such as last modified date, character encoding, server name, and version, and more, which is absent in FTP. Here are some more interesting comparisons between HTTP and FTP.